Okay, so now we'll start with the problems. So the first problem is we need to find the inverse Z transform of 2z square plus 3z divided by z plus 2 into z minus 4. Okay, and now we need let's write the u of z. We know that the u of z is equal to this term, that is I've written it here. Okay, so now let's use the partial fraction rule. We know that divided by z plus 2 into z minus 4. Okay, so now generally we write it as a into z plus 2 plus b into z minus 4, right? But in this case I've told you that if there is if it is of the form z plus a and z minus a, we need to multiply z to the numerator, right? So I've done the same thing, and now let's consider this as equation star. Okay, so now we need to make we need to make these two numerators denominators cancel out each other. For that we need to take the LCM for this term. Okay, in order to find the values for a and b. Okay, so now let's take the LCM for this term. So this becomes az into cross multiply z minus 4 plus bz into z plus 2 divided by z plus 2 into z minus 4. So these two denominators gets cancelled out. So the remaining terms are 2z square plus 3z is equal to az into z minus 4 plus bz into z plus 2. Okay, so now let's take this equation as equation 1. So now we need to find the values for a and b. Okay, so in order to find the values for a and b, we need to substitute some of the values for z. Okay, so now let's first find the value for b. Okay, if you can do in any case, you can first find the a as well. So I prefer to find the value of b first. Okay, so in order to find the value of b, right, we need to make this term equal to 0, such a way that we need to substitute the value for z in order to make this term equal to 0. So how to make this term equal to 0? In order to make this term equal to 0, we can make this term equal to 0, right? We know that anything into 0 is 0. So how to make this term equal to 0? It's simple. See, it's z minus 4, right? In order to make this is equal to 0, we need to substitute the value of z as 4, right? If we substitute the value of z is equal to 4, and then we can write it as 4 minus 4 is equal to 0. So if this becomes 0, automatically az into 0 is 0. So we can neglect this term to find the value of b. Okay, so in similar way we need to solve all these problems. Okay, so first we need to put the value of z is equal to 4 in order to make this term equal to 0. Okay, wherever there is z, right, in this whole equation we need to put the value of z as 4. Okay, so now let's put that 2 into z square, that is 4 square, plus 3 into 4 is equal to a into 4 into 4 minus 4 plus b into 4 into 4 plus 2. So now let's solve this. 4 square is 16, 16 2s are 32, 32 plus 3 4s are 12, 32 plus 12 is equal to 44, is equal to 4a into 0 plus 4b into 6. So this becomes 0. 44 is equal to 4 into 6, 24, 24b. Therefore b is equal to 44 by 24. So we can use the 4 table. So the final value of b which we got is 11 by 6 by putting the value of z is equal to 4. Similarly, in order to find the value of a, right, we need to make this term equal to 0. So now how to make this term equal to 0? Same thing, we need to make this term equal to 0. Okay, so here we have z plus 2. How to make this 0? Let's put the value of z as minus 2. If we put z as minus 2, we get minus 2 plus 2, that is equal to 0. 0 into anything is equal to 0. So we can make this term 0. So in the second case, we need to put the value of z is equal to minus 2. Okay. Okay, so now let's 2 into minus 2 whole square plus 3 into minus 2 is equal to minus 2a minus 2 minus 4 minus 2b minus 2 plus 2. This is 0, right? We can directly write it as 0. So now let's solve this. Minus 2 whole square is plus 4. 4 2s are 8 minus 6. That is 2 is equal to minus 2a into minus 2 minus 4 is minus 6. 2 is equal to minus 2 into minus 6 is plus 12, right? 12 by a. Therefore, a is equal to 2 by 12 is equal to 1 by 6. So we found the value of a as 1 by 6. Okay, now let's substitute the value of a and b, in which we have taken a equation star, right? So now let's see what the equation star becomes. So this is a required equation star, that is 2z square plus 3z divided by z plus 2 into z minus 4 is equal to, the value of a is now 1 by 6, right? So let's write that 1 by 6 first outside into z by z plus 2 plus the value of b is 11 by 6 into z by z minus 4. So now nothing, now in this case we need to take z inverse on both the sides, okay? By taking z inverse of both the sides, let's take z inverse on both sides. By taking z inverse of both sides, we get the required quotient. That is, we need to find the z inverse of this, right? So similarly, we get z inverse on this side. Let's take it and we'll find the required z inverse of this term. Okay. Here, if we take z inverse on for this term, the linear property says that this constant term we need to take outside. Okay. So now we'll solve that. So what we get, z inverse of 1 by 6 into z by z plus 2 plus z inverse of 11 by 6 into z by z minus 4. Now as per the linear property, let's take the constant terms outside. 1 by 6 into z inverse of z by z plus 2 plus 11 by 6 into z inverse of z by z minus 4. Okay, so now let's take the z inverse. So let's if we take the z inverse of z by z plus 2, but the formula we have it as z by z minus a, right? Z by z minus a. The z inverse of z by z minus a is equal to a power n, but we have it as z by z plus 2. So we can say that this is equal to z by z minus of minus 2, that is z by z minus of a. So the value of a here is minus 2. Therefore the z inverse we can write it as minus 2 to the power n. Similarly here, z inverse of z by z minus 4, this is straightforward, z by z minus a. In place of a there is 4, so this is equal to 4 power n. So this is your required inverse Z transform of the partial fraction which is given in the question. Okay. Similarly, we are going to solve 3 to 4 problems related to this partial fraction in order to make you clear about the concept. Okay. We'll get to the next. Okay, so now the question goes like this for this case. If z transform of un or u of z is equal to 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4, then we need to find the values for u1, u2 and u3. So for these u1, u2, u3 up to un, we have written some of the standard formulas in my explanation session. Okay. So using those standard formulas, we need to find the values for u1, u2 and u3. Okay. So now we need, since for finding the value for u1, we need to find the value for u0 first. So now we are going to start with u0. So the u naught formula says that we have written it, limit tends from z tending to infinity u of z. Okay, so now write it down, tending to infinity, u of z is 2z square plus 3z plus 12 divided by z minus 1 whole power 4. U naught is equal to limit z tends to infinity. So now we need to take this z square term outside. Okay, let's try to take this z square term outside and let's write the remaining terms. Okay, in the numerator let's take z square outside. So what are the terms remaining? 2 plus, since there is already a z, so in order to, if we take z square outside, the remaining term would be 3 by z. Similarly here only 12 is remaining, so in order, if we take z square outside, so we need to have another z square, so this becomes 12 by z square. And similarly in the new denominator, take z power 4 outside, so the remaining term is 1 minus 1 by z to the power 4. Okay, so now we can cancel this z square and or z square, since here, so here z square would remain. So finally let's apply the limit, that is z tending to infinity. Okay, so this becomes 0, so 2 plus 3 by infinity plus 12 by infinity, so infinity square is infinity itself, divided by z square, that is infinity square, into 1 minus 1 by infinity whole to the power 4. 2 plus anything divided by infinity, we know that it is 0. Okay, plus again anything divided by infinity is 0, divided by infinity square. Infinity square is again 0. 1 minus 1 by infinity is again 0 to the power 4. So 2 plus 0 is 2, divided by 1 minus 0 is 1. So this becomes 0. So the final answer for u naught will become as 0. Okay. So similarly now we need to find u1. Now so let's find u1. Z into u of z. So the required u of z is z minus 1 to the power 4 minus u naught, that is 0. Z tending to infinity again. Here let's take z square outside. So if we take z square outside, so z into z square will become z cube. So directly we'll write z cube outside, and again the same thing, 2 plus 3 by z plus 12 by z square, divided by, again in the denominator let's take z power 4 outside, 1 minus 1 by z whole to the power 4. Again by calculating this we get the value of u1 as 0. Okay, since after substituting the limits as infinity everywhere. Okay, now let's find u2. So this is the formula for u2, z square into u of z minus u naught minus u1 z inverse. Okay, so now let's substitute the values. Z square into the u of z is 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4 minus 0 minus u1 into u1 is 0, so u1 0 into z inverse is 0 again, so we can write it as 0. Limit z tending to infinity. Again, let's take z square outside. So since there is a z square outside, so z square into z square would become z to the power 4 into again 2 plus 3z plus 3 by z plus 12 by z square. 0 minus 0 is 0, I'm not going to write that. And again take z power 4 outside in the denominator. 1 minus 1 by z to the power 4. So here we can cancel this z power 4. Okay, so the remaining term is 2 plus 3 by z plus 12 by z square divided by 1 minus 1 by z whole to the power 4. So now let's apply this condition, limit z tending to infinity. So the final answer becomes 2 plus 3 by infinity is 0, 12 by infinity square is again 0 divided by 1 minus 1 by infinity is 0 whole to the power 4. So 2 by 1 minus 0 is 1, 1 to the power 4 is 1. So the required value of u2 is equal to 2. Okay. So now again in the same way we are going to find u3. So now before finding the value for u3, we need to remember this identity, because this identity we are going to use while finding u3. So the identity is a minus b whole to the power 4. That is a power 4 minus 4a cube b plus 6a square b square minus 4a cube b cube plus b power 4. We are going to use this identity, and we are going to expand one term, okay, in order to make the problem easier. Okay, so we are going to use this identity only in case if we are finding u3. Okay, so please make a note of this. So we know that u3 we have defined it, that is z cube into u of z. This z cube remains outside. Okay, this u of z term is there, right? This term that should be in one bracket, and this z cube is separate and separate term outside, so don't merge with this together. Okay, so z cube into u of z minus u naught minus u1 z inverse minus u2 z to the power minus 2. Okay, so now let's simplify. Z cube remains outside. U of z is 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4 minus 0 minus 0 minus 2 by, let's u2 is 2, right, and z to the power minus 2, let's bring it to the denominator, so it becomes 2 by z square. Okay, now we need to take the LCM. Before that, let's write these two terms together. Z minus 1 whole to the power 4 minus 2 by z square. So now let's take the LCM for these two terms. That is, let's first write the denominators by multiplying, and now z square into 2z square plus 3z plus 12 minus 2 into z minus 1 whole to the power 4, right? So now u3 becomes z cube into, z cube is outside, and now let's multiply z square to each of the terms. So it becomes 2z to the power 4 plus 3z cube plus 12z square minus 2 into, now we are going to apply this a minus b whole to the power 4 formula. Okay, we have written it, right? So what does this become? So z a to the power 4, so z to the power 4 plus 4z cube plus 6z square, 6a square b square, right? So it becomes 6z square minus 4ab cube, so 4z plus 1 divided by z square into z minus 1 whole to the power 4. Okay, this z cube is separate. Okay, don't think that it's directly to the denominator. So now let's further simplify this. Z cube into plus 3z cube plus 12z square. So now let's multiply minus 2 to all the terms. It becomes minus 2z to the power 4 minus 8z cube minus 12z square minus into minus plus 8z minus 2 divided by z square into z minus 1 to the power 4. So now we can cancel some of the terms here. 2z to the power 4 gets cancelled, 12z square gets cancelled, and we'll write the remaining terms. So the remaining terms are z cube is outside, 11z cube plus 8z minus 2 divided by z square into z minus 1 whole to the power 4. So now let's again take few terms outside. So this z cube is outside, right? In this term, let's take this z cube outside. So this becomes z cube into z cube, and 11 remains plus 8 by z minus 2 by z square divided by, again in this we will take z to the power 4 outside. Since there is already a z square outside, z square into z to the power 4, 1 minus 1 by z whole to the power 4. So now we can cancel these two terms. Since z cube into z cube is z to the power 6, and also z square into z to the power 4 is z to the power 6. So we can cancel these two terms. So the remaining term is 11 plus 8 by z minus 2 by z square divided by 1 minus 1 by z whole to the power 4. So now again let's apply the limit condition. That is 11 plus 8 by infinity is 0 minus, again this 2 by infinity square is become 0 divided by 1 minus 0 to the power 4. So 11 divided by 1. So the value of u3 which we got is 11. Okay, so now we have found the values for u1, u2 and u3. The value of u1 is 0, u2 is 2 and u3 is 11. Okay, so similar problem we are going to solve. Okay, I'm going to give that problem as homework. Okay, you guys try to solve it. Same type of problem. Okay, yeah, I'll give the question right now. Yeah, so this is your homework, or you can say it as one kind of an assignment. So please try this at home. Okay, the problem is if u of z is equal to, these things change. Denominator remains the same, 2z square plus 5z plus 14 divided by z minus 1 whole to the power 4. In this case we need to find u1, u2 and u3. Okay, I've solved one problem similar to this one. So please refer that problem and please try to solve this problem. Okay, so this ends your Z transforms. So in the next session you are going to start with the inverse Z transforms. Okay, that's also a simple concept. I am going to explain you in a few minutes in the next session, and we are going to start with the problems. Okay, in the next 2 to 3 sessions we are going to complete this module, that is Z transforms. So this half chapter is completed, the Z transform part is completed. So in the next session we are going to start with the inverse Z transforms. Okay, so yeah, that's all. Thank you. So this goes to first question of type 2, that is d cube y by dx cube plus y is equal to cos 2x. Okay, yeah, so here the value of r of x is cos 2x, and we can see that the value of a here is 2, right? Yeah, so the first step remains the same. To find the complementary functions, replace d cube by dx cube by d cube y plus y is equal to cos 2x. Take y common, so d cube plus 1 into y is equal to cos 2x. So now we need to put d is equal to m according to the auxiliary equation. So now this would be m cube plus 0m square plus 0m plus 1, right? That is equal to 0. This is again of the form cubic polynomial. Take the synthetic division, take all the coefficients, then try to find the first root. You see I have written the equation. Press the calc button. First value, let me take it as 0, 1, so minus 1. Yeah, see, for minus 1 I am getting the value as 0. So this is the first root. So bring this 1 down. Minus 1 into 1 is minus 1, 0 minus 1 minus 1. Minus 1 into minus 1 is plus 1, 0 plus 1 1. Minus 1 ones are minus 1. So this is 0. So by this we can write it as m square minus m plus 1 is equal to 0. Right? Now for this we need to use the quadratic formula. That is, the value of b here is minus 1. So minus of minus 1 is plus 1. Minus 1 whole square is 1. Minus 4 into 1 into 1, that is 4, divided by 2. So 1 plus or minus square root of minus 3 by 2. M is equal to minus 3 is there, right? So we can multiply it by I square by 2. M is equal to 1 plus or minus root 3i by 2. Okay, so this is your required root. So the total roots which we get here are minus 1 comma 1 plus or minus root 3i by 2. Okay, so we can write the complementary function as c1 e to the power, the first root is minus 1, plus, it's of the form alpha plus or minus I beta, so c2 cos beta x, the value of beta here is root 3 by 2 x, plus c3 sine root 3 by 2x into e to the power minus 1 by 2 x, right? So this is your yc. So now we need to find the particular integral. Now to find particular integral by p, we know that the formula is 1 by f of d into r of x. Okay, so yp 1 by the value of f of d here is d cube plus 1 into the r of x here is cos 2x. So now what we need to do, we need to replace d square by minus of a square, right? But here we don't have any d square term. So in order to bring the d square term, split this d cube, that is, we can write d cube as 1 divided by d into d square plus 1 cos 2x. So now here we have d square term. So now we know that the value of a here is 2. So minus of a square would be minus of 2 square, that is minus 4. We need to replace the value of d square by minus 4. Minus 4 plus 1 into cos 2x. So our yp would be cos 2x divided by minus 4d plus 1. Again, this is of the form alpha d plus or minus beta. So here it is of the form plus beta. So now the next step is we need to multiply both numerator and denominator by its conjugate, that is minus 4d. This is plus 1, right? So now we need to write it as minus 1 divided by minus 4d minus 1. So yp would be, so now multiply 4d to this term, that is minus 4d cos 2x minus of cos 2x, right? Minus 1 into cos 2x divided by, see in the new denominator term we can see that this is of the form a plus b a minus b. So we know that it is a square minus b square. So again write it in the form, that is it will be minus 4d the whole square minus 1 square. So now we can see that minus 4 into, we have d cos 2x here, right? So here we know that the d corresponds to d by dx, right? So that's it. Now we need to take the differentiation of cos 2x. Whenever there is d into cos 2x, we know that d is corresponds to d by dx. So we can write it as the differentiation of cos 2x is, the differentiation of cos is minus sine. So along with that we have here 2x. So we need to write minus 2 sine 2x minus cos 2x divided by 4d the whole square. 4 square minus 4 square is 16. So 16d square minus 1 square is 1. So yp is equal to minus 4 into minus 2 is 8 sine 2x minus cos 2x divided by 16d square minus 1. Okay. So now split the denominators. 8 sine 2x divided by 16d square minus 1 minus cos 2x 16d square minus 1. So again in the denominator term we have the d square term. So again we need to replace d square by minus of a square, where the value of a here is 2. So we need to replace d square by minus of 2 square, that is minus 4. So yp would be now 8 sine 2x divided by 16 into minus 4 into minus 1 minus cos 2x divided by 16 into again minus 4 into minus 1. So that is 8 sine 2x by minus 65, right? 16 4 the 64 and minus 64 minus 1 is minus 65. So this would be plus, because cos 2x divided by, we have in the denominator again minus 65. So here we have minus sign, so this would be plus 65. So your final answer for yp is, I'll write the positive term first, cos 2x minus 8 sine 2x by 65. So here in the denominator we have minus, right? I have just written minus here, so that we get both the denominators same. Yeah, so this is your required particular integral. So now we can write the general solution as y is equal to yc plus yp, right? So therefore y is, what we've got, the complementary function c1 e to the power minus x plus c2 cos root 3 by 2x plus c3 sine root 3 by 2x into e to the power minus 1 by 2x plus the particular integral is cos 2x minus 8 sine 2x by 65. So this is your required answer.